Hey everyone, my name's Rudy. I'm the CTO and a co-founder here at Yeti. Today I'm going to be talking about our experience using Django Channels on a recent client project and some of our trials and tribulations trying out a very new library. So first, start off a little story about the project and how we started to use Django Channels and why we're using it. So Jetpack is a client we worked with this year. Their application is now launched in the App Store. And we came across, while working on the app, a situation where we thought we needed real-time communication, that the app should be updating in real time, and that would be the best user experience. So what the app does is it essentially allows two people to buy and sell items to each other, whether that be like daily items you might need, regular, it might be food, it might be toothpaste, it might be butter for cooking, whatever you need from people locally, you can go and source it. And so part of that is a complicated flow around the buying and the selling, offering, suggesting what price you want to pay for it, accepting it, and then actually the fulfillment part, which is the delivering, getting the two people to meet up. So here's just a couple of screenshots related to some of those screens I talked about, and then even ending with reviewing how the buyer or seller was. So similar to some other maybe also like Lyft or Uber, other applications where there's also some kind of like on-demand active process that's happening. And in those apps, you want to see where your driver is at all times, for example, if you're the passenger, and the driver also wants to see where the passenger is. So the idea is this real-time updates is the same here. You want to be seeing exactly what the status is of your order, whether you are the person that is buying it or selling it. So we said, we're going to do this. We're going to do real-time updates. And then kind of what normally goes with that right now is this idea of WebSockets, if you're going to do real-time communication. So what is a WebSocket? I think the best way to describe this is a regular application. When you load something in your browser, you make a request to a server somewhere to get some information to load the page in your browser. That server gives a response, and then that kind of communication, that message is done. It's kind of request and response, and then it's over. What that means, though, is that after that message is over, if you want to get more information, the browser or the client or your app or your phone has to make another request to go get that information. The server has no idea about the client, the browser, the app, your phone, your laptop, whatever. It doesn't know how to push information back because there's just this one loop and it finishes. So with WebSockets, I think the easiest way to think about it is when you make the first request to the server, that request actually stays open. So there's a permanent line of communication. So that means if the server wants to send something to the client, it can do it whenever it wants because it's got an open, established channel to go do that. So a quick quote here about on imposter syndrome. I'm also planning on giving this talk at PyBay, which is a local Python conference. And so definitely this was our first foray into Django Channels, doing WebSockets, and also I'll talk about a little bit, but is writing async code in Python. So there's a whole bunch of new stuff, and I'm sure that we didn't do it 100% the right way, which I'll talk about as I point out a couple things. But so I am totally open, and I'm also hoping at that conference that some people come up and tell us about things we could have done differently or things we didn't even know, because there's actually very little out there right now about using Django Channels. There's just most of the documentation. So after all that, we wanted to use WebSockets. There's a couple of different options out there. Because we're already using Django for the application, it made sense, let's try out Django Channels. It is the Django officially supported way to do WebSockets. There's other programming languages, libraries, and whatnot are kind of already async by default, the nature of it. So if you have a JavaScript server, you kind of WebSockets more or less come out of the box because JavaScript is already running asynchronously. With Django and Python, with Python 3 and async IO, this has all just kind of become a possibility recently, and Python historically has not been an async language. So that's why you would have had to use some other service or spun up a different type of framework or library to even make this work. So it's cool. We chose to try out Django Channels. We started to look at the documentation and the GitHub and noticed that Django Channels 2.0 had literally been released in the past week or two. This is like right around February when we were starting on this part of the Jetpack app. So as you can see here, there was a major backwards incompatible rewrite that happened to support essentially async IO in Python 3 to run Django Channels. So it gave us a little bit of pause, but we decided to still go with Django Channels 2.0 anyways. It wouldn't make sense to do it in one, but some concerns that there might not be as much support out there, might be a little bit buggy because it was kind of brand new. So a little concerning, which I'll talk about. So really only the resources we had at our disposal was the documentation on Channels 2.0. Andrew Godwin's the main contributor, author of it. He also has a personal repo called Channels Examples, where he had a couple of simple apps that at least like showed you a real life example of how to set it up, which was super helpful. And then a lot of trial and error, since there was not a lot of answers on Stack Overflow about Channels 2.0. There was not really many other blog articles and tutorials on how to use Channels 2.0. There was plenty for Channels 1.0, but like I mentioned, it's backwards incompatible. And so most of the answers we found could be a little bit misleading because they're actually how to fix issues with version 1, not version 2. So a little bit out on our own, but the documentation was great, and it was awesome. There was an example repository, but we could tell that they were still like fixing bugs and making updates to 2.0 while we were working on it. Like I saw more examples get added to the examples repo while we were actively working on the feature, which was very interesting to be a bit on the bleeding edge of the Channels 2.0 stuff. So the documentation is great, and it gives a really thorough description of all the pieces of channels. So I'm not going to give a channels 101 talk. This is more or less about a couple of the trickiest bits that we ran into that weren't really described in documentation or in the example GitHub repo very well. So just a couple things to point out for anyone to jump into this to be helpful. I'm going to give the first few slides are just a little bit of a context so that we have some kind of shared vocabulary to talk about. So we're going to talk about consumers, routing, and auth, some of the basic stuff on how do you just set up channels quickly. So a consumer is essentially, the documentation describes it as the basic unit or building block of channels. So this is the one from the documentation that I'm showing here. It's a super basic. Imagine if you were in a chat room. The idea, right, it's the classic WebSocket example application. You're in a chat room. You imagine when someone else writes a message that you want to see that message in the chat room on your screen right away. So the idea is a lot of chat room apps, they might be polling. They might be constantly saying, hey, are there any new messages? But likely they're all using WebSockets. So what this is doing, there's three main methods. There's connect, which is when you first connect to the WebSocket. Receive, which is when the WebSocket receives a message from the client in the communication, and then disconnect. So these come out of the box, and you can write any logic or code you want to in here. So what this basic chat consumer is showing you, when someone connects, you get an anonymous username, and then it sends you the message, welcome to the chat. When you disconnect, it doesn't do anything, it just disconnects. But you can imagine a more complicated application. There might be some logic, some maybe entries in the database you want to make, maybe notifying other people when someone or something disconnects from the consumer. And then the receive block here, the idea is if you type /name and then your name in the chat room, it'll set that as your username and then send that back to you. That's what the if-else case is doing here. And then, or if you're just sending some other message, when it receives that message, it sends that message out to everyone that's listening to this consumer. So the bottom there where it's saying self.send, and it puts your username, : and then whatever message you sent. So super basic chat application. And this is really how it works. The WebSocket consumer that the chat consumer inherits from has a bunch of stuff under the hood that's doing things too for you as far as like the setup and teardown. So routing, how you connect it all up, it works pretty much like a standard Django URLs or some other Django library like Django REST framework configures your URLs. So you create a router. That's how it works for WebSockets. You add your URLs. So for Jetpack, we had there's two major kind of WebSocket endpoints that you could connect to. Those URLs just map to the consumer that it needs to go to. Django and Channels handles all of it matches the URL, right? It sends it over to the right consumer. And the other thing worth noting here is that there's this OAuth 2 middleware that's wrapping this. So Channels does have some out-of-the-box support for Django, authentication sessions, stuff like that. But it didn't have anything for something like OAuth 2, which is what we use with all of our standard backends when we're using Django REST framework and we're setting up authentication. So we had to write this ourselves. I did see in the documentation there was some updates around how this works since we've done this. So I'm not sure if it's gotten any easier. So the idea is we wrote this middleware. We kind of copied the already out-of-the-box middleware that came with Channels for sessions and then just stuck our OAuth into it. So here's the middleware. The important part here is the line where it says scope user equals simple lazy object. The simple lazy object is just a thing in Django, if you don't know, where it won't actually run the method that's in that Lambda until someone actually tries to access scope user. So it kind of just maintains a reference until someone actually tries to use it, and then it will go run the get user method and actually return the result of it. So nothing super crazy or important here. It's actually that get user method that does all the authentication stuff. So I just pulled out a block of it because this is the part of it that tripped us up a little bit. From my understanding, digging into this, you're not able to send headers through a WebSocket request. Could have been we were doing something wrong, I'm not sure, but from what I gathered, we weren't able to send any headers in. Normally, OAuth works, you send in an authorization header with an access token to get all this hooked up and working. So that wasn't going to work. We're running into a bunch of issues. So instead, we have to send up the token in the request outside of the header, but to continue to use all of our regular OAuth 2 stuff that we use with Django REST framework, we had to fake it. So we create a fake request, put the token that we got into the header in Django's meta object, which is essentially what it deserializes the headers into. And then we pass that along to the regular OAuth 2 library that we use, that we also use with Django REST framework. So this way we're sharing the same exact authentication with both all of our WebSocket requests and still all of our regular REST, Django REST framework, HTTP type communication as well. So this took a little bit of time to figure out. There was some stuff in the documentation around authentication, but nothing specifically around this use case. So the next part is kind of a slew of things related to async that were new for me, as well as on top of that stuff with WebSockets and Django channels that we're trying to figure out and how does this all work. So the first thing to show here, and there's a lot to unpack in just these few lines. So first, anywhere in your code where essentially you want an action to actually send a message to people that are listening on the WebSockets, you essentially get the channel layer, which is Django Channels' way of saying more or less getting, I'm sure they phrase it and have a much more tight description of this, but essentially the layer is all of the people that are listening and they're in different groups. And groups more or less just have an identifier that you're sending it out to. So you can have a bunch of different people all in the same group, and you can send a message to that group in Django Channels, and that message will go to everyone that's in the group. So you get the channel layer, and you can run that code essentially anywhere in your Django application. And then so there's a couple things we're doing here. I'm going to skip the async to sync. We'll talk about that in a second. But the channel layer .group send is the function, is the actual Django Channels function. And then we're passing it delivery.order.group name. So the idea is every order in our app has a group name And usually the people who are subscribed to it are the buyer and seller. There's usually two people in the group. There might be more people in the group when someone hasn't actually locked in that they're buying the order yet, and there might be multiple offers for an item. There actually might be then multiple people in the group, because let's say if the buyer picks one of those offers in the app, we need to tell all the other people who had offers out there that their offers got declined, for example. So we can use all this logic to just send it all out to a group at the same time, and Django Channels will handle actually sending the message out to everyone. So we do the group send method on channel layer. We pass it the group name, more or less the identifier of the group to send it out to. And then we do this type order.delivered, which is the type of the message. And I'll show on the next slide how that maps to the message that actually gets sent out. This is how we so from a lot of our Django REST framework code or just other logic that happens in the app, when something happens, someone clicks like, yes, I'm going to accept this offer. That still in Jetpack is a regular REST-based API call. That could also be a WebSocket request as well. But we didn't go that far. WebSockets is mostly just for sending messages. We didn't fully have it also receive everything. That could be an enhancement in the future. So the other tricky part about this is the async to sync up there. So the whole idea, now that we're mixing synchronous code and asynchronous code, all of the WebSocket consumer things are all running essentially on an event loop in async.io, and it's all asynchronous. So when we talk from the regular synchronous Django code to the other stuff, we need to call this async to sync function, and it's going to handle for us the switching over, calling the asynchronous code, handling the switching from doing non-blocking code over to the asynchronous code for us. There's a lot of stuff happening there that I'm probably not even all that really understanding of what's happening, but so we have async to sync sprinkled all around our code whenever we're making the connection. So remember I was saying that the type order.delivered is the type of the WebSocket message. That actually directly maps to the method in the consumer. So there's a method called order_delivered in the order consumer. And so this is a little bit of a tricky bit, but basically whatever type of message you pass, it tries to call that method in the consumer. Wasn't quite as straightforward right away. That's what it was actually doing or how it was working. So here is essentially we called that group send method. This gets called in the consumer. It's now running on async code. So this method in the order consumer is going to send out a message to everyone that's listening to the group. So the first thing we do is we actually get the order object from the database using the ORM. We actually are using Django REST Framework's serializers here to change the ORM object into JSON, which is also convenient because our front-end code, which already has models set up to take some of this JSON structure from our regular DRF endpoints, it can also, we were also able to reuse that for some of the WebSocket related messages as well. So that made the front end a little bit cleaner and easier to have kind of the same API contract between the regular REST APIs as well as the WebSocket. And then we send the JSON. So we send that down. We added this message type fields for some logic on the front end to know what status the order is in, what message is this that's being sent down. So we do some logic around that message type. I don't believe that is all required by channels. We kind of created this structure ourselves to make it easier. So that was kind of the sending messages and how do we go from regular synchronous Django code to the async code, which took a bit for me to wrap my head around. The next part was our backend code is usually 90% plus tested and covered by tests from all of our Django REST framework APIs. So I wanted to figure out how do we test this consumer code. And this turned out to be fairly tricky, not having any experience with async code at all. So first off, there's a lot going on here, and we'll just go top to bottom. At the top, you see these decorators at PyTest. Basically, we had to use a different Python test runner that would support running tests that are testing async code. We normally just use kind of the built-in test runner in Django's out-of-the-box stuff. So that was different. Then we have to add a couple of these things about how we're using, right, the async IO code. So we're running async. And also the Django DB stuff is because we're running these tests in asynchronous code, but to make this work, we also have to do some database operations, which are blocking. And so we have to run those synchronously. So you have to add both of these decorators to the test. And then as we're coming through here, you see that we're doing, I'm not going to give a one-on-one on Python async code because that's probably a whole nother talk. And I'm also not by any means an expert. But whenever you see that await keyword through all these lines of code, that's where we're calling a synchronous function and we're awaiting it to give us the response back. The middle block, which I'll just mention because there is a ton of documentation about this on Django Channels, is all Django Channels helper methods around actually testing the consumers. So that was great that all this was provided. We just needed to figure out a little bit how to string this all together with also doing and like setting up factories and test database entries, and all of that didn't seem quite as clear cut at the beginning. But basically, we can test the whole thing that we're sending a message to the consumer is sending a message out when a certain other thing happens. So we do some integration tests where we actually call a regular Django REST framework API, and then we check to make sure that that then caused a message to get sent out in the group and then go out to all the people in the group. So this is great, and we were able to give a lot of confidence that the code we were writing in WebSockets was working. Since this was new for us, if we didn't, we would be probably a bit more unsure and not as confident that all that's working. So I'll point again the two methods at the top there, get user and token and get order, just the other part of kind of stringing this all together. The get order method, this just does some regular Django database ORM operations. But this decorator is another thing you have to add to just say that this whole method is essentially needs to run synchronously. And so it's an easy way to just say, just run this whole method synchronously, which is why we can await it in the other tests. So that was a little tricky, trying to figure exactly how to set all this up. That wasn't as clear cut. The last thing that I'm going to talk about is then also deploying it. This was the other thing that was touched upon in the documentation. But from what I gather, there's a lot of ways to do this. And so there wasn't quite a recommended one way to do this in the documentation. So hosting and actually deploying it, we had to make a lot of decisions and figure some stuff out. So this is from the top of our Nginx configuration file. So normally we have some servers, we have a load balancer, we're running Nginx on the servers to hand stuff off, usually to Unicorn to run all of our Django processes and code. To run all of this WebSocket stuff, you have to have something different that's actually running it and serving it. So ASGI is the asynchronous protocol that's similar to WSGI, which is the regular protocol we use for passing stuff off to synchronous Django code. So there's a couple different ways I heard people talk about this. You could just run the whole Django application using ASGI, stop using WSGI whatsoever. And so even WebSocket and HTTP requests would all just go through the ASGI server. I decided, since this is our first foray into it, and that feels maybe riskier, we actually split them. So we're still running both. Every WebSocket request gets served over to ASCII, and every regular synchronous request gets served over to WSGI. And just so in case I just felt more comfortable, it seemed pretty clear out there that there was no real consensus on the way to do it. You'll see that at the end of this bottom one for the ASCII server, we're connecting to this thing called Daphne, while the top one's Unicorn. Unicorn is probably more recognizable. Daphne is the Django Channels specific asynchronous server that was created by Andrew Godwin. I have seen that there's a few other ones that have started to pop up that you could also use. At the time, I don't think any of those were really ready, but I also know Tom Christie, who wrote Django REST Framework, I think has been working also on a bunch of asynchronous stuff as well, and a new API framework. And I think what he's created is also an alternative for Daphne that you could use as well. And I think he's getting a lot of support for that. I'm also interested to see how that might affect Django REST Framework and other things in the future, if all of that kind of comes together and it doesn't have to be so disjointed. The one other thing I'll show too that was tricky is actually how do you, so the first thing was just about, okay, a web request comes into the server. How do we know where to send it to? So we were just showing before, right? This, if it's an HTTP request, we're sending it off to Unicorn. If it's a WebSocket request, we send it off to Daphne, which then are both running Django processes. But this is just the routing from Nginx. So to actually run the servers, there's two different things that we had to add to our normal Ansible orchestration setup. There's a lot of variables here because we use Ansible, which is a deployment management tool. So when these all get deployed, all those kind of like template tags variables get replaced by values. But so we're seeing here, there's two different ones. The top one is we're actually running Daphne, the server. The bottom one is you have to also run ASCII workers. So I think it's analogous to the having like the Unicorn workers, or if you were to run Celery, you would have the Celery workers as well. So you have to set up both of these, which again, there's just a lot of kind of trial and error around deploying and getting this set up on a staging server and having kind of the right configuration. And there wasn't really as many examples around this that I could find of people hosting this and actually running it in production. So this is kind of another place where we got tripped up, but it's been working. In production, apps on the iOS and Android stores, people have been delivering and buying, and it's all been working out, and the real-time communication works really well. It's worth noting the front-end stuff we're doing was React Native, so that'd be a whole nother talk to show the kind of the front-end side of it. Maybe Kevin would love to give the equal part of how this all works on the front end of what we did sometime as a talk. But that's a whole nother thing. So that's it. Thanks.